we're going to look at the ambiguous case. This is when we are given two sides and an angle, and we have three-letter designations for triangles in terms of what we're given. And the law of sines, and in the law of sines, we have really like some different situations here. We have angle, side, angle. We also have angle, angle, side. But lastly here, we're giving two sides and an angle, which is called the side-side angle. You can see why they organize letters this way. And the two sides and an angle are given, and that means that you can have one of three situations. You can have one triangle that fits the bill. You can actually have two triangles that fit the bill, and I'm going to show you a trick to designate between 1, 2, and no triangle fitting at all. In this situation, the no triangle fitting at all is going to just train wreck on you. And in the examples 5 through 10 that I have here, these 6 examples, I have 2 that work out to be one triangle, 2 of them that work out to be 2 triangles, and 2 of them that work out to be no triangles at all. So now what I'm going to do here is I'm going to start with just a scrap or simple picture. This is a triangle that's going to be an isosceles triangle. I just call it the Dorito that many students can see here. And the capital letters on the outside designate the angles. Capital letters are angles, small lowercase letters are sides. So lowercase c, lowercase b, lowercase a is the corresponding side to those angles. And notice they're straight across from each other. So when I draw the triangle for the first time, like in problem 5, I'm going to just put what I know here, that my letter B, the side length is 4, and letter C, side length is 3, and my B angle is going to be 40 degrees. Now, the two that are across from each other, that sets up my relationship there. That's my first part of the law of sines. And as a review, the law of sines is sine A over A equals sine B over B, and is equal to sine C over C. And we just are going to set 2 of these equal to each other and then solve for whatever we're missing, be it the side or the angle. And in these situations, we're missing the angles because we're only given one angle and 2 sides, so we have to find the missing side and here, or the missing angle, and that here would then be angle C. So we're going to put sine of capital letter C over 3. Now to solve for C, we're going to do some cross multiplication. So 3 times sine of 40 is equal to 4 times sine of C. And then I'm going to divide everything by 4 here. So 3 sine of 40 divided by 4 is equal to the sine of C. Now, before you actually type this into your calculator, please make sure that your calculator is in degree mode. If it is not in degree mode, then all of these problems will not work because we're typing in these angle measurements in degrees and not radians. Most calculators default to radians. So if you click on the mode key on your Texas Instruments graphing calculator, usually near the top of the screen you can see that there is a mode for radian and degree. Please make sure you are in the degree mode. So if you go 3 times sine of 40 divided by 4, you get an approximate answer of 0.48. And again, I keep all the decimals on my calculator, and that's when I do the next step, I'll get a more accurate answer because I got 0.48 is equal to sine of C, or approximately sine of C. And to get C by itself, we have to take the inverse of both sides. Taking the inverse of the inverse, or the inverse sine of C, will just give me C. And then if I then have on the other side the inverse sine of 0.48, this will give me an approximation of C is approximately the angle measurement of, 28.82 degrees. There we go. All right, so there's my angle C. Now, what I need to do is I need to do this trick, and it's basically checking to see if there might be a second possibility for angle C. What I have to do is take 180 degrees and subtract 28.82. This is going to give me an answer, and in this case, it gives me 151.18 degrees. And I have to verify if this could be a possibility in the triangle that I have. And if I have 151 degrees in for angle C, 151 and 40 is over 180, so this is a one triangle solution. So now that I've verified that angle C is the, in fact, only angle that we can have here, since 40 degrees and 28.82 degrees can fit inside of a 180 degree triangle, by default, I can then subtract these two from 180 degrees, or 28.82 from 140 degrees, and get an approximate of 111.18 degrees. So now I know my angle C, I know my angle A, and the only thing that's left is side A. So I need to find this side right there. So what I'll do is go back to my original setup. I want to stick with what I'm given in case I made a mistake along the way with angle C or side of C. So here's my original relationship to find the side length A. I'm going to have my angle right there, angle A, and solve for A. This is another cross multiplication problem. 4 times sine of 111.18 degrees is equal to A times sine of 40. So what I'm going to do is divide both sides by sine of 40. Now, I think from now on, when I do these problems, I'm going to take a quick step through them, which means I'm going to multiply across and then divide by the number that was across from the letter I was solving, if I'm solving for a side. It makes for a much faster problem. So it's multiplying and dividing. This is just using the cross multiplication or means and extremes property to get done what I want to get done. So my A is going to be, or this side length is going to be what this combination is going to be, 4 times sine of 111.18 degrees divided by sine of 40. And if I do that, my A is approximately 5.8. So that is the side length, and decidedly, this side length is the biggest because it is across from the 111.18 degrees. And it might be a good idea to verify that the smallest side is across from the smallest angle, so that 28.82 degrees was across from C, 3 right there, so 3 is the smallest side, biggest side is 5.8. And so what I want to show you as I move to the next problem is that I actually did a scan of these problems here. So here is that problem number 5 with C being, let's see, angle B, well actually I mistakenly put my C and my B in opposite directions here. So again, I'm looking at my picture and that's wrong. That should be a B and that should be, so I'm sorry about that. B should be on top, B should be on bottom. But you get the idea that the 40 is across from the 4 right there. And my C is across from what I found to be my 29 degree angle. And then my 111 degree angle is across from 5.8. I did some rounding on the triangle here to make it look a little bit better there. So in light of this, let's move on to the next problem here. All right, so this is problem number 6. Okay, so in problem number 6 here, we have a new triangle. That triangle is again, I'll just draw my Dorito here. And let's see here. I'm gonna put my, and just keep working with B on top here. Might as well keep that pattern going, even if the pictures I've drawn are a little wrong there. 120 degrees. I mean, the pictures are done accurately. It's just I had the letters in the wrong spot. And there we go. So 120 degrees, and that's across from 2. So the big question here is, well, what angle do I have to find? And the angle I have to find is angle C, because that's how I'm going to get my law of sines to work out here. So this is the sine of 120 degrees over 2 is equal to the sine of C over 1. All right, so if now what's kind of nice about this, I don't actually need to do cross multiply because this right-hand side is equal to the sine of C. Sine of C divided by 1 is sine of C. And this is sine of 120 divided by 2 is equal to sine of C. If I actually do that, I will get 0.43 is equal to sine of C. Take the inverse of both sides. The inverse of the inverse sine of C is just C. And the inverse sine of 0.43 gives me an angle measurement for C that is 25.67 degrees. That's for C. Now what I'm going to do is test to see if this angle measurement right here can be anything other than 25.67 degrees. And to do that, I'm going to make a little box here, and I'm going to subtract 180 degrees and 25.67. Now if I subtract these two, what I get is 154.33. Now you'll notice that if I try to put that in for angle C, 120 and 154 adds up to over 180 degrees, so this is a one triangle problem. Therefore, this is my C angle then. I'm just going to subtract my 120 and 25.67 from 180 degrees, and I find out my A angle. Capital A would then be equal to, oh, sorry, not my capital A, I already know A. My capital B, there we go. My capital B angle is equal to approximately 34.33 degrees. All right, so now I have my three angles. So now what I need to find, now that I know that this is 34.33 degrees, and I knew that this was 25.67 degrees, now I just need to find this missing side length b. So over here, I'm going to have the sine of 120 divided by 2. This is the original setup from the original problem, is equal to the sine of 34.33 degrees divided by b. Now, again, since I'm going to try to do this quickly, you would multiply these two together and then divide by sine of 120. So the sine of 34.33 times 2, that's a 34 there, all over sine of 120. Again, if your calc's in degree mode, everything's going to work out just fine to find the side length b. And side length b is equal to 1.3. So there's my side length b, and you'll notice that 1.3 is not as small as 1, and 1 was across from the 25.67 degrees, and the b was across from 34.33, and the biggest side, which was 2, was across from the 120. And again, as I move on to the next problem here, I will show you the picture. Okay, and again, you can see that I have my letters in the different places, but you can see that I have my 120 across from the 2, my 34 is across from the 1.3, and the 1 is across from the 26. So it works. And we're about ready to get into problem number 7, which is the first of our problems that actually have more than one solution. So here we go, getting into tricky problems. And I have pictures of this too to show you at the end, to show you that, yeah, there are possibilities that you can have two different triangles from this given information. Because what we're given in this information is that b is equal to 40 degrees. The side across of it is 2. So there's our setup there, sine of 40 over 2. And we know side length c, which is 3, so we need to find angle c right there. So there's our sine of c divided by 3. So to find c, we're going to go 3 times sine of 40 divided by 2. And this is going to give us what sine of c is equal to. So this times this divided by this. 3 times sine of 40 divided by 2. And this gives us an answer of 0.96. Really close to that limit of domain right there. Okay, so, and then we take the inverse of that. We take the inverse of both sides. So we're going to take the inverse of sine of 0.96 to find what that is, because on the other side we take the inverse sine of c to get c, and the inverse sine of 0.96 or 96 hundredths is 74.62 degrees, and that's equal to c. Now what I'm going to do is run my little test up here. Okay, so here's a test. Now what I'm going to do is I'm going to subtract 180 from 74.62, and this time I'm going to get an answer of 105.38 degrees. Now you'll notice that if I take 135.38 degrees and put that in this triangle, so C has that possibility of 105.38 degrees, 105 and 40 still is under 180 degrees. And if it's still under 180 degrees, this has to be a contingency of a second triangle. So what I'm about to do is just kind of divide this now into two parts, because I now have found a possibility for angle C, but there's a second possibility. And the second possibility exists when we subtract from 180 degrees and find that there's an angle that fits inside of the triangle still, because 40 degrees was small enough to accommodate it. So this will give us two different answers for angle C, which means we're going to have two different answers for angle A, and I'm using subscripts to denote that. So in our first case, 180 minus 40 minus 74.62 gives me 63.38 degrees. So there's my answer for A sub 1. And then in this situation where I had an obtuse angle instead of a barely acute angle, this not 90 degrees, I'm going to subtract 40 from 180 minus 40 minus 105.38. And that's going to give me 34.62 degrees. So what this means is I'm going to have two different answers for my missing side. And the missing side is going to be over here. It's going to be my missing side for letter A. And this is going to obviously give me two answers because they're two different pictures. So on the one hand, we're going to have the sine of 40 divided by 2 is equal to the sine of 65.38 divided by A. So 2 times sine of 65.38 divided by sine of 40. My A is going to be approximately 2.83 in unit lengths right there for my side length. Over here, I'm going to have the sine of 40 divided by 2. Again, starting out with what we're starting off with over here. And we're going to set that equal to the sine of 34.62 divided by A. So A times sine of 40. We're going to go 2 times 34.62 and then divide by sine of 40. And what this is going to give me, A is going to be equal to 1.77. Now, to really see these out, I'm going to move to the pictures of what these two problems look like. So you may want to copy this down before I move to the next part of the video here. Okay, you can pause or move on because I need to erase this and show you what the pictures look like. All right, so problem number 7's pictures. All right, so you'll notice that we're starting off with 40 degrees and 2. So notice that this picture has 40 degrees and 2. And we found out that this missing angle was 75. And that would make this approximately 65. Notice that, you know, this almost looks equilateral. I mean, I'm not drawing it to scale with rulers or measuring it with protractors, but it's pretty good there. And you'll notice that there's the second option. The second option is when you have 40 and 2, but this is an obtuse angle. And you can see that this would be 35, a little bit less than a 45-degree angle. But all the side lengths correspond, where you got 35, the smallest angle is across from 1.77, medium-sized angle, medium-sized side, largest angle, largest side. Whew, these two example problems do take a long time, but we're now going to be given a little bit of a break in problem number 8 and actually problem number 9. And I'm going to have some fun with this too, because these are going to be the situations that actually do not work. Illustrate that by, first of all, just drawing my Dorito like this. And let's see, my angle A is 70 degrees. My side length, which is 3, is going to be here. My side length of 7 is over here. So we need to figure out my angle B. So we're going to have the sine of 70 over 3. This is the match for angle A and side A. Then we got sine of B is equal to 7. Now, if you go sine of 70 times 7 divided by 3, you get 2.19 equals sine of B. Well, we're going to have a problem here, because if we take the inverse sine of 2.19, and on the other side we take the inverse sine of B to get B, your calculator is going to give you a mistake. And the reason why, and this is going to be a domain problem. If you remember back in the previous chapter, that the inverse sine has a domain that goes from negative pi over 2 to pi over 2. And if you want to convert that to degrees, it would be from negative 90 degrees to 90 degrees. But if you look on a unit circle, that would mean that the sine at negative 90 degrees is negative 1, and the sine at positive 90 degrees is 1. So if we have a number that's not between negative 1 and 1, then we have a domain problem. So there is no solution to this problem. And if you want to see the picture of it, I drew a picture to show you that this is a problem. There's problem 8 right there. You see, here's the angle A, which is 70. Here's side length B, which is 7. Now, I drew it on the bottom here. Normally, I had it on the left-hand side, but you'll notice that no matter how I manipulate this side length A, which is only 3 long, you notice that 70-degree angle mark basically telescopes this to the point where I just can't get it. No matter how long or short the side is, this point will never reach to the end. 3 is just too short to reach to this end from a 70-degree angle. Even if I, had the 70-degree, if I had the 3, right here, it just would not get there in time. The same thing is going to go for number 9. I might as well just show this to you right now. You'll see that this 95-degree angle, since it kind of fixes this spot, that 4, no matter how I swing it, if I swing it in the northwestern direction, like just on this hinge there, I'm never going to be able to touch this piece that's at 95-degree angle. And in fact, 95 degree, this is a little less than 95 degrees. 95 would be even more profound. That number 8 and number 9 are going to be the no solution problems in this section. And again, I want to run through problem number 9 just to show that to you. So what we would have, again, to draw our Dorito, All right, so what we're going to have be 95 degrees, and I put my 95 over here. This is side length B, which is going to be, oh wait, I had my B on top. Sorry, now I'm confusing myself there. So 95 on top, and again, the perspectives are all, your way of doing things here. Let me just put this as side C, and that's what we're going to try to find angle C from side C first. So we're going to have sine of 95 degrees divided by 4, and this is equal to the sine of C divided by 5. If we go 5 times sine of 95 divided by 4, here's what you get. You get, so you got to trust me on this one here. Since I didn't write this down, I would lose it all if I went to my calculator on my computer. But anyway, doing this and then taking the inverse sine of this is going to give you a number that's greater than 1. And in doing so, this is going to be a no solution problem, as I showed you on the previous picture. Okay, so let's do our last problem, which will have 2 possible answers. Okay, so let me draw my Dorito. And again, I'm just choosing this as to just get the setups here. My B is 4, my B is 40 degrees, my angle B. All right, so that's going to be my setup there. Sine of 40 degrees over 4 is equal to 5, which is over here. And this is my side C, so sine of C divided by 5. All right, so if I do my sine of 40 times 5 divided by 4, I get 0.80 approximately is equal to the sine of C. Now, if you find that you've been doing these problems with me and you're getting answers that are approximately close, I tend to use all the 10 digits on the calculator when doing inverses. So if you see, differences between yours and mine, but they're very small differences, it's probably where they're coming from. So if I take the inverse sine of 0.8, this gives me a C, which is 53.46 degrees. All right, so now what I'm going to do is going to make a box here for my test. So I go 180 divided or minus 53.46. All right, now what I get there is I'm going to get, 126.54 degrees. Now, you can see that if I take that 126.54 and look inside my original shape, which has 40, that I still have room for an angle in there. So this is going to be a 2-solution problem. So I have now one of my possible answers for C, and I'm going to make a dividing break right there. And here's my second possible answer for C. This is C sub 2, 126.54 degrees. All right, so what I'm about to do now is I'm going to solve for 2 different A's. This is my A sub 1. And my A sub 1 is going to be 85.54. Wow. Hold on a second here. 85-ish, 54 degrees. There's my A sub 1. Here's my A sub 2. My A sub 2 is going to be 13.46 degrees. And where I'm getting these angle A's from is I'm subtracting my 40 and 46 from 180 to get 85.84. And then I'm subtracting 40 and my 126.54 from 180 to get 13.46. And now I take my original problem, set that equal to the sine of 85.54 divided by A. And if I do my 4 times sine of 85.54 divided by sine of 40, my A is approximately 6.21. All right, and then here, circling the things I found. Over here, I have sine of 40 divided by 4 is equal to the sine of 126.54 degrees divided by A. Now, to find my A times sine of 40, 4 times sine of 126.54 divided by sine of 40, my A is equal to, in this case, 1.45. Now, before I leave you in this video, I want to show you the pictures of that. So let's go, if you've written that down, you can pause, of course. Let's go to the picture here. All right, let's go to the picture one more time. There we go. All right, so let's move that up. So now you've seen problem number 10, where I was given 40 and 4. Again, I put these in this position. Again, A, B, and C is all relevant to inner perspective. But you'll notice that the 86 degrees, which is what I found for my angle A, is across from 6.21, which is my largest side. I was given the 5, the 40, and the 4, and you'll notice that the smallest angle has a small side, and the medium has the medium angle, medium side, large angle, large side. Now here's the cool picture that we found, looking at that obtuse alternative here. So if we look at the obtuse angle, we're noticing that we're still starting with the 5, the 4, and the 40. Now what we've done is we found that our angle A is 126 degrees, which is across from the 5, which is our largest side. Our other angle's 14, which is really small, but that's okay. We found a really small side over here, which is 1.45. Well, I hope this has helped with the ambiguous case. Thank you for watching. Send me an email if you've got any questions. Thanks again for watching.